Okay. Hello. Am I audible?
Yes, sir.
Okay, great. So is week 11 PA questions are discussed in the previous session? Okay. Anyone confirm? Or anyway, we can discuss it today. No worries. Okay. So I hope my screen is visible. So we don't have week 12 content in city course, just 11 week content is there. Okay. So throughout the remaining session, we'll discuss about your doubts and we'll revise the concept from week 1 to 11. Okay. This session is basically for week 11, but from next session, I will do the revision for end term. Okay.
From next time we will
You are not audible if someone is speaking. Can you speak little louder? Hello. Hello.
Yes, sir.
I'm audible, right?
Yes, sir.
Okay, great. So you can see this week 11 question. So week 11 we'll discuss about the recursion part. Very, very important topic, recursion. Okay. Now what is a recursion here? So we are calling a function inside the function. Okay. So we are calling the same function again and again inside the function here. That's what a recursion is simply. Okay. Okay. Great. So first let me discuss about this particular question. It will be easier to understand the concept. Then we'll move on to previous questions, right? So you can see here we have a pseudo code. We need to find out the value of a, b, and are the two positive integers. Assume that a and b are two positive integers, and pseudo code is given to us. Okay, you can see this procedure. We are defining a calculate a comma b, and if you see here again, we are calling the same function inside the same this particular function here, right? That is what a recursion is, calling a function inside the same function here again and again, right? Now, what we need to find out the value of 12 comma 3. So let's consider here 12 comma 3. So value of A is basically 12 and the value of B is basically a 3 here. Okay. So just see how I am solving this particular question. Okay. So that will be easier to follow. Okay. So here we have a calculate A equals to 12 and B equals to 3. Difference is equals to 0. If A less than B, is this a true? Whether A is less than B, you can see 12 less than 3. No, not correct. Then we'll go for this statement. If A equal to B, no, right? That is not a correct. What about this one? We are taking a difference now. Difference is what? A minus B, that is basically 12 minus 3 is 9 here. Now, we are checking whether difference that is 9 greater than a B. Yes, that is a true. Then we are going to return this. Now, what we are returning? We are calling this function again. Now, here the value of difference that is D will be 9 and this B will be what? A 3 here, right? Now, we have to call this function. We have to do same procedure again for this particular values here, okay? So let me write it down here like this. So now the value of A will become 9, the B will become 3. Again, we are checking if A is less than B. No, not true. Again, A equal to B, not true. Again, we are doing a difference here. So 9 minus 3, that is basically 6. Again, 6 greater than 3. Yes. So again, we are going to call the function here, right? So we are going to call calculate difference, comma, B. That is basically what here? 6, comma, 3 here, right? So again, we are calling the same function here. Again, we need to do the same thing. Again, 6 and 3 here. A is 6 and B is 3. Okay. So you can see here 6 less than 3? No. Equal to 3? No. Difference is what? 6 minus 3 will be 3. Again, we are checking whether difference is equals to B. Is this true? Yes, anyone? No, right?
No.
So, yeah. Okay. So this is not true. Then we go to else statement. Return B comma DIF. So here 3 comma 3 like that. Again, we are going to call this particular function here. Okay. Now, if we go back here, now A is 3 and B is 3 here. Difference 0. No. A less than 3. No. Is A equal to B? Yes. That is a true here. If A equals to B, we are going to return what? B here. What's the value of B? That is basically a 3 here. Right? Is that the okay? Anyone, any doubt here how we got a 3? This is how we can solve this particular problem, okay? We have Recursion here, we have defined one particular procedure and we are calling the same procedure again and again inside this particular procedure. We need to follow the same thing by changing the parameters here. That's it. Okay. The correct answer for this particular question will be a 3. You can see option number C here. Okay. Now, similarly, you can try to solve this question. Okay. We just need to follow what we have done. That's it. Okay. Okay. So again, you can see here, we need to find out how many times the procedure calculate called in order to compute this particular value here, right? So include the first call in your answer. So how we solve this particular question? Yes, anyone? How to solve this question? 14 comma 17, and we need to find out how many times we are going to calculate, we are going to call this particular function here. 14 comma 3, 14 comma 17. Okay. So you can see here, right? The value of A is basically 14, value of B is 17 here, right? And then we are applying the same thing, right? Difference is 0. No. A less than B here. Yes. Now, in this case, A is less than B. That is basically true here, right? So we are going to calculate B comma A now. So we have reversed this one. That will be 17 comma 14. Again, we are going to calculate the same thing here. Okay. So we have called this particular procedure one time, second time, right? Now tell me how we are going to calculate. Do we need to solve this question or there is a formula to find out this answer? Does anyone? Yes? Okay. So again, same thing here, right? So just see how we are calling this particular procedure and just count how many times this is getting called here. That's it. Okay. So calculate first time. Again, here we are doing one more time. That's it. 17 comma 14. Again, calculating this particular procedure, right? But the value of A is 17 now and the value of B is 14 now here, right? This will not be true. This will not be true. Again, difference will be what? 17 minus 14. That is basically 3. So difference is 3. Value of B is 14 here. Is this true? No. Then we go to else statement. Again, we are going to call this particular function here like that. And again, we need to proceed with the same thing here. The value of B is basically 14 and the difference is what? 3 here. Okay. So in this way, you can just call this particular procedure and find out the value for this particular case 17 comma 12. Sorry, 17 comma 14. And how many times you're calling the function, you can count that. Okay. Anyone, any doubt?
Excuse
No
me,
one is.
how we calculate? Suppose A is 3 and B is 3.
Yeah. So in the
So
previous
sorry,
question,
sir, are we discussing week 11?
yeah, week 11 questions only. This yeah. So see, in the previous question, like what we have solved, the value of A and B was 3, 3. In that case, what happens? You can see 3 less than 3, not true. Here you can see 3 equals to 3. Now this will become true and then we are going to return the value of B. That's it. Okay. So
No,
what
no,
are the
but difference is equal to 0, na? First, second line.
no, difference is not equals to 0. Difference is basically a 3. We are calling this particular function here. We are checking. So we are, again we reinitializing the value of difference to 0.
Okay.
Right. So here again we are calculating a difference here. When we call this particular function, again we have to follow all the code here. So we are reinitializing value of difference to 0. And again here we are calculating the value. So that whatever the difference will come, again we'll compare with this and this here. Okay. But whenever the value of A and B are equal, we are going to return the value of B here. That's it. Okay. So if you follow this particular process, you are going to get the answer 1 here. Okay. So I guess answer is 1. Okay. Yeah. So same thing like what we have discussed in this first question, just the values are changed. Process is basically the same one. Okay.
Sir, for that 14, 17, how the value is 1 instead of 3? We call the 3 times, right? 1 plus 1 plus 1.
No. This is the value of this output here, right? Calculate 14, 17. Okay. And for that
Oh,
purpose, how many times we are calling the function, we need to do entire process here, right? We have not gone through all the process here. Like that, you have to count how many times we are calling this particular function. Okay. So you can see answer will be 11 time here. Okay. So I guess sorry, 9 time you can 9. Yeah, 9 times. Sorry. So 9 times we
okay.
have to execute this particular function, and then we are going to get the answer 1 here. Okay. So what we are doing here actually, 17, 14, answer was 1, and here we have 12, 3, answer was 3 here, right? So if you look at this particular question, for any two positive integers a and b, what does a and b return here? It returns LCM of two numbers, it SCF of two numbers, it returns LCM of the two numbers provided a greater than b, or SCF a greater than b, like that. Okay. So when we have a equals to 12 and b equals to 3, our answer was what? 3 here, right? And when we have, sorry, 14 and 17, and here we have, yeah, 14 and 17. So when value of a was 14 and the b was 17, answer was 1 here. So what we can say, which option is correct here?
It returns the HCF of the two numbers.
Yeah. So you can see highest common factor of the two numbers will be correct answer. You can see in this case 1, and in this case is basically a 3 here, right? So it will return the SCF of two numbers here. That is what option B is correct here. Okay. So this question depends on these two questions. If you have solved these two, you can easily understand that. Okay. Okay. The result of expression was to, yeah. So if we replace the value of a and b like that, a comma b or b comma a, so what is the result of the following expression? If this will be true, whether we are going to get the same answer?
Yes, sir.
Yes, because anywhere we have got calculating SCF of that, so it will return the same. Okay. So a simple, in week 11 we are just discussing recursion. In your end term also you can expect 1 or 2 question based on this recursion topic. Very, very important. Okay. Either 1 or 2 question will be there from recursion. So please try to solve all the PA and GA questions, right? Now let's discuss this question number 1 now. Okay. So first read the statement carefully. Unique is a procedure that accepts list L as an input here. Okay. It returns the unique element in the list after removing the duplicate. If L is basically a list of integers, it will remove the duplicates and it will give us the unique elements here, right? Select the correct code fragment to complete the pseudocode here. So here you can see procedure unique L. Init element is basically a empty list here. If length of L is less than or equal to 1, what does this mean? Yes, anyone? Length of L is less than equals to 1 means what?
It will check the length of the list
And
L, and if
it's
it's
a
equal
double
to
digit.
1,
Hello?
or
Double digit or single digit number.
hello, sir.
Yes. It will check whether the list is empty or just have one element in that, right? If list is empty, it means what? Length of L will be 0, right? Or if it is equals to 1, like it means what? There is only one element in that particular list, right? So if length of L is less than equals to 1, that means what? It has only one element and we are going to return that particular element here. Okay. So that's the case. Now init item equals to initial L here. So let's do one thing. We consider a sample list. Let's say 2, 3, 2, 2, 3, 1, 4, and 3. And this will give us unique L should give us what? Unique elements here. That is basically 2, 3, 1, and 4. That's it. Okay. Now let's take this as an input and we should be able to get this as an output here. Now just go option wise here. What about option number A? How this will work? We have this L as input. and this we want in the output, unique elements, right? Like that. So here, anyway, the value of length L is not less than or equals to 1, so we are not going to execute this one. Init element, initial of L. What is initial of L? Yes, anyone? What is init of L? What this will give us?
2.
2, 2,
No.
3, 1, 4.
All the elements of list except the last element.
Last one.
So except this 3, we are going to get 2, 2, 3, 1, 4 in the initial elements here, right? So that is what we have, initial elements, and here we have last. Okay. Now what is last of L? Last element of the list.
Last
is
element of the list.
3.
3.
And here we have a unique, init element except the last element. Now what is member function will check? Member will take what? Here we have list, here we have element. It will check whether this element is a part of the list or not. If this is true, then it will return true. Otherwise, it will return false. So member function will check whether the element is part of list or not. So here we have 3, and here we have initial list is 1. Is this true? Is 3 is a part of list of this list?
Yes.
Yes,
Yes,
you can
sir.
see here we have 3. It means what? We have to return the unique element here. Again, we are calling the same function here again. Okay. Now, we have to take this list as an input, this one. Okay. In the next iteration, again, we need to apply the same thing here. So anyway, length is not equals to 1. We are not going to return L. Again, init element will be what? Initial list, that will be 2, 2, 3, 1 only, this one only, right? That's it. Now, again, we are using this one. What is last of L in this case now? Do we
4.
take this as an input? 4. And this will be like this, right? Whether 4 is a member of this list? No.
No, sir.
No.
So we will go to else statement. What we are doing here? Tell me. So again, we are calling a function here, plus last of EL here, right? So what is last of EL?
4. 4.
4,
No, sorry, 3.
right? Last of
Yes, sir,
L will
4.
be 4. Okay. And here, what we are getting? Unique element. Okay. So again, we are going to call this particular function, but the input will be this time is what? This much only. Okay. Again, same thing, length is not equals to 1. Initial will be 2, 2, 3 only, and then we have a 1 here, right? Sorry. Again, we are checking whether 1 is part of the list or not. No, that is not true. Again, we are going to return this one. So remember, here we have 4, and again we are calling this function. The output of this will be what? Again, we are calling the function with the input 2, 2, 3 plus last of element, that is basically 1 here. Okay. But is this correct? Last of L. Here we are getting a list, and here we are getting an integer value, element value. Can we Can we merge both the list here like this? We have one list and we have one element.
No, sir.
No, it should be both the list, then only we can merge two lists here, right? So anyway, option A is not correct. This should be the list here, right? So we'll discuss the same thing. You can see the option number B is doing the same thing here. Same thing, only here we are putting L in the format of list here, right? But anyway, I will discuss this one, okay? So see, in the previous iteration, the value of last L was 4, and unique element, again, we are taking 2, 2, 3, 1 as the input here. Again, if you go through the entire procedure, what we are going to get? Again, we are checking last of L is basically what? 1 here. 1 is not the part of member. It will return, go to L statement. Again, we are calling the same procedure here, but this time 2, 2, 3. So again, we are calling a unique element 2, 2, 3 plus here the last element is what we have 1 here, right? Again, same thing. Again, length of L It's not equals to less than 1. So we are not going to return L. Init element, initial value of L, that is basically 2, 2 only, right? Last element will be a 3. Are you getting what we are doing here? We are taking this as an input now.
So can you
Last
repeat? Can you repeat with the like modification in the example, like what is happening to the list after each iteration?
Yeah, so here we are considering we have a list here, like option number B we are discussing, okay? Because anyway we cannot merge the list with the element, right? So option
Yes,
A
sir.
is not correct. So we are discussing option number B. So like what happened? We are taking list as an input every time. We are removing the one element from the last. You can see here, right? We are checking whether that element is a part of the remaining list or not. If that is true, again, we are going to call the function. If that is false, then we are going to else statement here. We are taking the
What is unique of initial elements doing? Actually, the function, the procedure unique of initial elements, it is defined in the beginning, na?
yeah, so you can see this is what it is defined, unique EL, right? So we are calling the same function inside the same function here. That is what a recursion is. We are calling a function inside the function. So,
Okay.
right, it will return the value only if this line execute. Otherwise, we are going to call the function here. Okay.
Yeah.
Yeah. So if you see in the previous iteration, this was our list. Last element was 4. So that's why we have taken this 2, 2, 3, 1 as an input here, right? 2, 2, 3, 1 as an input. Again, we are checking the last element is basically 1. 1 is part of list.
Yes.
No. So we'll
No.
go to else statement. So init element is what? You can see it is defined here. Init element is basically initial list. So except the last element, we are going to consider the initial elements here. So here initial elements will be 2, 2, 3 and the last element will be 1. So now we are going to call the function unique 2, 2, 3 with the last element 1. Again, after this we have, and after this here I am writing. Again 2, 2, 3 will be taken as an input here, right? Again, it is not, again initial element will be empty. Length L is not less than 1. So again, we'll execute this one. It will be init of L. That is basically removing the last element will be 2, 2. And here the last element is basically 3. Again, 3 is not a part of initial elements. So again, it will return false. So we go to else statement. Again, same thing here. We are going to call the function unique with the list 2, 2 as the input plus the last element is basically a 3 here, right? Now again, we are calling the function here. Now what happens? 2, 2. Tell me what will happen now. Input is 2, 2 list, right? Is this true? No. Init element will be what? Initial list. So that will be what? How many elements? Only one. That is 2 here, right? And then again we are
Yes.
executing this code. Last of element will be what? 2
Two.
only. 2, and here we have a 2. Whether 2 is a part of list?
Yes, sir.
Yes. So we are going to return the unique element. Again, we are going to call this particular function here, that is unique of 2. That's it. Okay. Now what is unique of 2? Again, same function here we are calling. Now what will happen? Tell me.
Return L.
Yeah. So you can see initially empty, but length of L now in this case, that is basically 1. Now this condition is getting satisfied. Okay. So in the recursion, there will be always one condition which will return the value. Okay. Otherwise, it will keep calling the function again and again. So there must be some stopping a criteria also in the recursion here. Otherwise, if we skip this part, it is going to call the function again and again here, right? So there must be some stopping criteria as well in the recursion. So you can see here, we are going to return the value of L. That is basically what 2 here, right? So simple 2. The output of this will be a 2 here. Okay. So this is how we are executed. Now see what we have to do. This is the output of this particular function, what we have called. Now, this will be taken as input for this particular function. Now here that will be a 2. So 2 plus 3 will be what? 2, 3. Now this is basically output of this particular function, right? This will be what? 2, 3 plus 1. That is basically 2, 3, 1. And this is basically output of this particular function here. That will be what? Plus 4. plus 4 here. So in the end, we are getting 2, 3, 1, 4 like that. You can see here. Okay, this is the output what we got here. So option B is correct here. Okay, because of this one. Option A is not correct because here we are not taking a list. Okay, we cannot merge. Anyone? Any doubt? So whenever you come across this type of thing, right, when we need to take the input.
In the first option, it is saying return unique of initial elements, but in the second option, it is simply returning initial elements.
Oh, okay, yeah. So this is not the correct here. Sorry. We need to find out unique element here. This is also not correct. Unique element is missing. Here, yeah, this is correct. Unique element, right? Yeah. So option D is correct here. Sorry. So here, yeah. The difference between option A and B is what? This as well as unique element here. If we don't have a unique element, it means what? We are going to return whatever the list we have. But that is not true. We have a duplicate also, right? So you can see this is also not correct. Option D is correct here. Unique element and last option. Okay. Okay. We have discussed option number A, but here we just required this list. We have considered that, and that is what the option number D is. Okay. So whenever you come across recursion problem, always go in that particular manner. Okay. Call this particular function, put the arrow, find out the output of that particular call. Again, if we are calling again the function, again put the arrow, and then we go back to do the merging here. Okay. Or whatever the process we have to do. Okay. So this is how we are going to get the unique list here. Anyone, any doubt here? So please try to solve, practice more problem based on recursion because this will take time in exam, okay? So you have to follow this particular process only. You can see previous term question, there was 2 question in every end term exam based on the recursion, okay? So you can also expect 1 or 2 question in this end term also. Okay. Now here we have a second question. A word is said to be a palindrome if the word obtained by reversing is the same as the original word. For example, madam is a palindrome, right? Let X be the row in the words table. At the end of execution of the following pseudocode, flag stores true if the word in row X is palindrome and false otherwise. Okay. Select the correct implementation of the procedure is palindrome. So we are going to check whether that particular word is palindrome or not. What is palindrome? Basically obtained by the reversing same as the original word here. So if we reverse the word, we are going to get the same word here. For example, madam, if we reverse that, we'll get the same word. Any other example of palindrome? Yes, anyone?
Nitin.
Nitin, N-I-T-I-N, Nitin, yes, correct. Then we have level also. Level, yeah, correct. So these are the few words. Even if we reverse that, we are going to get the same word here, right? Now, if the word is a palindrome, it should return true. Otherwise, it should return false. That's the question here. Let's see. Word list is basically empty list. Flag is false initially. Word list is explode x dot word. Explode x dot word means what? It will create a list of all the elements here. For example, we have madam here. So explode x dot word will create m comma a comma d comma a comma m. This is what the thing is, right? Explode x dot word. Now flag is basically is palindrome. So we are calling a procedure here by taking this as a input here. So for every word, we'll create a word list. We'll see this one, and then we are going to call this particular function here. Let's see which satisfies. First, we'll go with the option number A here. Okay. So our list is basically what? M comma A comma D comma A comma F. Now, this should return true for this particular word, otherwise false. Okay. So we are taking this as an input. If length of L is less than equals to 1, we are going to return true. Okay. So what we are doing here, yes, is this true? First of L is not equals to last of L. first element of the list, last element of the list. Is this correct? It is equal or not equal?
Yes, sir, it's correct.
Equal.
First element and last element should be equal.
Yeah, so here we have not equal. This means it is false, right? If this
Yes.
is false, then we are going to else statement here. Again, we are calling this function here again, but this time input is what? Init of rest of L. What's the output of this one? Tell me. Init of rest of L.
Rest of elements taking the first instead of leaving the first part and taking the rest, and from int means they are just removing the first and last question. They are just removing the first and last.
Yeah,
A,
so
D,
rest
A.
of
ADA.
correct. Yeah, so rest of L will remove the first element and it will give us the remaining element. Init will remove the last element, it will give us the remaining element. So rest will remove the first element here. We left with A, D, A, M. Init will remove the last element here. We got A, comma, D, comma, A. So we are removing the first and last element here in this particular case. Okay. Now again, we are going to call this particular procedure. Now the input is A, comma, D, comma, A. Again, we are taking length is less than 1. It will return true, but not correct. What about this one? Last of first of L, last of L. Is this not equal? This is equal, right? Again, we'll go to else statement. Again, we do the same thing. Here output will be what? D only, right?
Yes, sir.
Now, again, call the function. Length is equals to 1. Yes, it is going to return true here. Okay. So for this particular case, it is returning a true, right?
Yes.
Is this correct?
One doubt. In this case, palindrome means it will just send it's okay, it's a palindrome, it's true. But if we insert a non-palindrome mode, means what will happen?
It should return false. Okay. If it is a non-palindrome, it should return false here. Let's say, for example, any word we can take. So let's say, for example, word only, right? So W, comma O, comma R, comma D. So whenever this condition gets satisfied, first of L is not equals to last of L. So W is not equals to D. This is true. So we are going to return false here, right? So this will work in this particular case as well. But what if we have length, word is basically level. This is also 4, this is also 5. Can we get the word with the even number of characters? Because anyway we are removing 1, 1. So at the last will be 1 here. So let's try any word palindrome having even number of characters. Noon. Noon will say. Right? This is also a palindrome. Noon. Now let's see. So again, not equal. First of L, last of L, not equal. We'll go to else statement. We'll remove the first and last element. That will be 0, comma 0. Okay. So sorry, O, comma O. Again, we'll call this particular function. Length of L is basically not equals to 1. Again, this is not equal. Again, we are going to call the function. Again, we are going to remove this both the element. Now in this case, the list will be empty here. The list is empty. Again, length of L will be equals to 0 and this is going to return true here, right? So yeah, this is working in this particular case as well. So option A looks correct here, right? What is the correct option here? A and C. Okay. Option A is correct here. Anyone, any doubt like what we have discussed here? So whenever the first and last word is
Still,
not
I'm
equal,
confused. Like, can you teach once more, once again?
okay. So we need to find out if the word is palindrome, it should return true. Otherwise, it should return false here. Okay. You can take this example or this example for a true case here, right? So first we are checking if the length is less than equals to 1. If only one element is remaining or empty list is there, it is going to return true, right? So 1 will be there whenever the word is having the odd number of character here. It will be empty list when we have an even number of a character like that. So if we are checking if the first element is equals to last element of that particular word, okay. So if you consider any palindrome, this should satisfy it, okay. First element should be equals to the last element. If that is not equal, then it should be written false directly. This is what we are doing here. Yes, right? If first element is equal to last element, so this will be false. Then we'll go to else statement here. And here what we are doing here, we are removing the first and last element. So rest of L is what? Removing the first element. We'll remove this first element. Then this will be taken as an input to the init function. Init will remove the last element. So we are going to remove the last element. So this both will remove the first and last element from the list. So here we already check if those are equal. If it is equal, then it will remove the both the elements here, right? This is how we are going to check whether the word is palindrome or not. If it is not equal, then simply it is going to return false because anyway, the word is not a palindrome. Okay. Is this okay? Okay.
Yes.
Let's see option number B. Is this correct? Here we have length of L equals to 1. Last of L equals to, sorry, first of L equals to last of L, and then we are going to call this particular function. Else we are going to return false. So same thing, but we have what we have done here, right? If it is equal, we have to execute this one. Same thing we are doing here as well. If it is not equal, then we have to return false, and here also we are going to return false here. But what's the difference here? Is this true or what?
The length is 1 here,
Then
line
can be
number
less than.
second.
Yeah.
If it is a even number word, then it is not going to be executed.
Yeah. If the word is known like this, then the length of L that will be empty. That is basically 0. So we are not going to execute this one, right? So this is not going to return true for that particular case. So option B is not correct. Okay. This will work only when we have a odd number of characters. What about C? Same thing here. What same logic is there, but here we have put less than equals to 1. Okay. Simple what we have discussed in option number A. If this is true, we are going to return false. Otherwise, go for this particular statement. So here we have just changed the condition. We have make it equal, and we are going to return at this one. Okay. Else it is going to return the false. Okay. So this is also correct. Same thing. What about option number D?
It will
Why
be
this
incorrect.
option is
Well, the
why this is not correct?
line number 5 and 6 is incorrect here.
Yeah.
If
So
it
we
is
are
a
only
second
Sir,
line.
because in this they
uh,
just given rest. Okay, I
We are
think
only
this
checking
is
first and
correct only.
second, first and last word.
yeah. So we are
The
only
alphabet.
checking if the first and last character is same. It is going to return true. But what about the other characters here, right? If you just check first and last character, EB, doesn't matter how many characters we are, it is going to return true. But that is not the correct here. We have to check whether we are getting the same word after reversing the element or not. So option D is also not correct here. Only option A and C are the correct. Okay. Anyone, any doubt? Any doubt in week 11? Because we already discussed all the questions from PA. Okay. So recursion is very, very important topic. You can expect 2 questions based on this particular topic in the end term. Okay. So please solve PA, already solved PA plus solve GA as well, and plus end term previous year questions if you find out. Okay. So you have to practice for this recursion because either you can take a sample example like what we have done here, right? Or if it is a integer value like that, then you have to follow this particular entire process. Okay? But it will be easier if you go in this particular manner. Okay, the output of a previous call, write down the arrow, again call that particular function, do the same process again call the function for a different input and do in this manner because it will be easier to go back and do the processing whatever is required. Okay, in this case we are merging, so like that. Okay. Okay. Anyone? Any question from week 11?
Sir, can
Or
you
week
discuss
10?
week 11 theory part, summary part?
Summary we already discussed in Friday's session, and anyway, we just have one important topic, that is recursion here. Okay, this is the only topic we have in week 11. Okay, let me
So,
check.
Sir, I could not understand from that actually, na, from that was discussed. So that is why I am saying.
Okay. Here we have DFS and recursion part here. Okay. So recursion is important. DFS will see DFS recursion. So DFS is with the backtracking thing. So this is what we have done. Procedure. Any specific concept you are not able to understand?
So DFS.
Okay. Okay. Correct. Okay. So we'll discuss this activity question. Stop. Is this visible?
Yes, sir.
Okay, great. So this activity question we are discussing 11.1, I guess. Yeah. So what is a DFS? That is depth first search. Okay. Depth first search. We use this DFS or BFS for searching the element inside particular a tree here, we can say, right? If you want to find out a path between the two nodes, we apply these algorithms, right? Let's say, for example, I want to find out whether H is present in this particular, or I want to reach to S from A, which path we can go, okay? So here, depth first search means what? We'll go in one particular depth, okay? So let's say, for example, I am drawing these nodes here, like this, okay? Let's say, for example, here we have A, here we have our goal state G here, okay? This is the node what we want to, where we want to reach. This is our starting a node here. Okay. This is visible, right? Whatever I'm writing.
Yes, sir.
Okay, great. So what happens in the case of depth first search? We first fix any one direction. Either we'll go on the right side of that node or left side of that particular node here, right? So generally we go in the left side of that particular node. We'll try to see whether that particular node is having our goal state or not. So I will go to this particular node. I will check whether this node is G. No, not true. Then I have two options here. I can go on this direction as well as this direction as well. So this node or this node here. But in the case of DFS, what we follow, we go in a particular direction till we reach the dead end and then we backtrack. Okay. This is what DFS is. We go in this direction. So we are going on left side here of this particular node. So we are not going to explore this node. After this node, we'll go in this particular direction only. Doesn't matter how many nodes here we have. We'll go with this particular node. Again, we'll check whether our this node is goal state or not. No, that's not true. Then we go for a next node here like this. We'll not go in this particular direction unless we reach the dead end. Let's say, for example, we have reached this particular node as well, and we are checking whether this node is G. No, that is not true here, right? Now we didn't find the goal in this particular branch, right? And we don't have any other nodes to explore after this. Now what we are going to do, we are going to backtrack to the previous node. So backtracking to previous node here, right? So we'll backtrack to a previous node. This is a previous node. And now I already explored the left side. Now I will go on the right side of this particular node. I already explored this particular last node, both the side of a node, because I don't have any branches to go. Then I will go to a previous node here, backtrack previous node, and then I will follow in this particular direction. Again, I will compare our goal state, no, our goal state, no, our goal state, no, right? Then again, we'll backtrack to the previous node. Again, we'll backtrack to previous node because we don't have any other node to explore here. Again, we'll backtrack to this previous node. Again, we'll backtrack to previous this particular node 10. Again, we'll compare whether, so we already compared this node, right? And then we'll go in this particular direction. Again, we'll compare whether our node is G or not. No. Again, we'll backtrack to a previous node and then we'll go in this particular direction. Okay. This is how DFS works. We go in one particular step. If we found the element, we say our search is complete, or we found the element. Otherwise, we backtrack to a previous element and then we go in another direction like that. Okay. Is this clear? Hello?
Yes, sir. Yes,
Okay.
sir.
Now let's apply the same thing here. We have a tree. What is the longest path of the node in the given tree? So longest path defined as the path with maximum number of vertices here. Right? So here do we need to apply a DFS? Let me read the question. Right. So here we are just interested in finding out the longest path here, right? Okay, I will apply a DFS to...
Sir, but in this case, we have two longest path, right? A, B, C, G, H, A, B, C, E, F. We have two longest path, both have equal length.
Yeah. So both will be the answer here. So it's MSQ question. Okay. So here, yeah, this question is not for DFS, but let's try to explore the longest path. Longest path means what? With the maximum number of vertices. And if you look at the options here, let me check the options. One is A, B, C, E, F, A, B, C, G, F, A, B, C, G, H, right? A, B, C, E, F, E, B, C, F, A, B, C, G, F. Then we have A, B, C, G, H, E, H. A, B, C, G, H, A, B, C, E, H, right? So in this case, you can go option wise. So we are interested in this particular question. We'll apply DFS also to this particular graph. Let's see. So first, A, B, C, E, F. We'll go to A, then we'll go to B, then we'll go to C, then we'll go to E, then we'll go to F. Yeah, this is correct. This is longest path. How many edges or vertices we are exploring? 1, 2, 3, 4, 5. A, B, C, E, F. Right? What about second option? A, B, C, G, F. Is this correct? A, B, C, G, F. We can go to A, then we can go to B, we can go to C, we can go to D, we can go to A, B, C. After that, G. After that, we can go to H here. But here it is mentioned F, so we cannot go directly to F like that. No, so option B is not correct. A, B, C, E, F, A, B, C, G, H are correct here. Similarly, from E to H, we cannot go. Okay, so simple question here. But let's try to apply DFS here. Now I want to find out the node H here. Okay, I will start with A. I will always explore the node in the alphabetical manner. Okay, I'm writing a note here. Explore the node
Sir,
in
but
alphabetical.
sir, but we need to consider from the node which doesn't have any in degree.
Yeah, so here we have to start with the A. It is not mentioned here, but yeah, our starting node is basically A here. So there is no input path here, right? So in degree is 0 here, right? Otherwise, we'll specify in the question that we have to start from this particular node. Okay, but yeah, whenever you can see if that node is not missing, we'll start with the in degree
मटके का
0
दे दो
node.
जरा, मैं गिलास में डालता हूँ।
Please
दे दो,
mute.
मैं सुन रहा हूँ ये।
Okay, right. Now we always explore the node in alphabetical manner. It means what? If we from A, I can go to B and D, but first alphabetical order is basically B, then I will go to B like that. Okay. Now what about the first thing A? Then I will go to this alphabetical manner, that is B here, right? Whether it's H or not, no, we'll compare. Then we go to C here, right? Because I can go to C only. But from C, where I can go E to G, E and G. But according to the node, we are going to explore in alphabetical manner. So E will come first. I will go to E. We didn't found the node H. Again, go for a F here. We didn't found the node F. Then we have to backtrack here because I don't have any other node to explore on this node vertices. If we backtrack to E, again, I don't have any other node to explore here as well on the right side. I will backtrack to C. Now here I already explored this particular branch. I will go on this particular slide now, right? Then here you can see A, B, C, and then we have explored E and F, and now you can see we'll compare G with H. No, not correct. And then we'll compare H with H. Yes, this is we found the goal state here, right? So first we have explored A, then B, then C, then E, then F. If you see order of exploration of node, it will be like this: A, B, C, E, F, and then G and H. This is how we explore the order here in the case of a DFS. BFS works differently. We don't have that, I guess, in the syllabus. Okay. But I hope you understand the concept of backtracking here. This is what sir is trying to explain. Okay. Backtracking to a previous unexplored node. And same concept we are applying in the recursion as well. Okay. So again, we are calling the function. Once we execute, we are backtracking to a previous called function and we are doing some process, right? That is what we are doing here. Okay. Is this clear? Anyone, any doubt now about DFS? The same concept you are going to learn in your PDSA course, okay? Python data structures and algorithm course, DFS, BFS in detail with the code, pseudo, with the actual Python code. But I hope the concept is clear
So
about
why
DFS. Right?
A, B, C, E, F, G, H?
No, this is the order in which we have explored the node. Explore the nodes. Order in which we have explored the nodes. First, we go to A, B, C. Then, according to the node, we have mentioned explore the node in alphabetical manner. Since we are following DFS, we need to go to an entire branch till dead end. If we didn't found, then we backtrack to a previous unexplored node like that. So first we explore A, then B, then C, then E, then F, then we backtrack to previous unexplored node, this particular branch here. Then we have visited G and then H. This is what we got here. But order of exploration of the nodes is basically A, B, C, E, F, G, H, like that. Okay. If you want to explore D, then we have to go backtrack again. Then we explore D here, like that. This is how DFS works. We go in certain depth and then we backtrack. Okay. So this is only in the city course. We have a lot more in detail about DFS, BFS in our PDSA course. But the main thing about the recursion here in week 11, it is backtracking to a previous node, a previous function got here. Okay. I hope example of DFS is clear, right? Okay. Anyone, any other doubt from week 11 or from week 10 or any other previous week? Week 12 content is not there. Only week 11 is there. So if you have any doubt from the previous week also, you can ask. So in week 12, we have few tutorials. Just go through those tutorials. That will be good enough. We don't have any assignments in week 12. Anyone, any doubts? Anyone, any question? From the next session, I will do a revision from week 1 to 11. You can also solve the previous term question. If you have any doubt, you can ask in the session about those questions. Okay.
Can you discuss, sir, some like graph concepts?
Graph concept. Okay. So, like, what is in that? Like adjacency matrix or what? We have discussed adjacency matrix in the previous sessions, I guess, in the previous Saturday sessions. Yeah, can you tell me like which concept you want to?
Okay, 1 minute, sir, I'm telling.
So in graph theory, we have for city course, we mostly have directed graph, number of degree in degree node, what is clique of size 3, like that type of questions you can expect. Okay. Okay. First tell me what is in degree and what is out degree. Yes, we already discussed what is in degree, out degree.
In degree is the number of edges coming
Number of
to edge,
incoming edges, right?
incoming edges. Yes, sir.
Yeah. Out degree is basically outgoing edges. That's it. So if we ask for what is the out degree of node 3, OD of node 3, what's the answer?
It will be 1, sir.
1 only. We are only one edge is there. What's the out degree or in degree of a node 1? Only one edge is coming
1.
inside, that is also 1. Okay. This is what the concept of in degree, out degree, simple concept. Now, what is a clique? Yes, anyone tell me the clique?
When each node is connected to every other node.
Yes. So we can say the clique of order 2 or a size 2 here. So size 2 means what? In 2 nodes, both the nodes are connected to each other. This is a size 2. If we say clique of size 3 here, it means what? Here we have 3 nodes, and in that every node is connected to each other. Now, at this particular graph, can you tell me what's the clique of size 3 here? Just tell me clique of size 3.
So no click of size 3 present.
Then can click be directed?
Yes, directed.
So it will be 0, 1, 3.
Sir, in directed graph,
No,
click is
yeah.
not present, no?
Yeah, directed. Yeah, only the edges you have to check. Okay, not directed graph. Okay, yeah. So don't consider here any direction. Just tell me click whether present or not. Size 3. Consider we don't have any arrow here. Okay. It's
0, 1, and 3.
0, 1, and
yes.
3.
You can see this particular thing 0, 1, and 3. So 0 is connected to other 2 nodes. 1 is also connected to other 2 nodes. Similarly, 3 is also connected to other 2 nodes. So it is a size of a click of size 3 here. size 4 click is present in this particular graph?
1, 3, 2, 4.
1, 3, 2, 4. No,
No,
because
it will
what we are saying, every node is connected to every other node. So one is
Okay,
connected
okay,
to
no, no,
2
no.
and 3, but not to 4, right?
Yeah, 2 and 3 are not connected, and 1, 4 are not connected.
So the click of size 4 will be like this. Here we have 4 nodes and they are connected to each other, right? So 0 is connected to 1, 2, 3, 2 is connected to 0, 1, 3, like that. This is the example of click with size 4. Okay. Size 4. Click of size 2 is basically just 2 nodes like this. Okay. So here we have all the nodes present like that. Okay. Okay. Any other concept you want to discuss about the graph? Yes, anyone?
Sir, in DFS, we use the queue data structure, and in BFS. In DFS, we use stack data structure. Sir, how last in, last out, that concept I don't understand.
BFS, yeah.
Yes.
Right. So BFS, I think, is not a part of a course, right? So yeah, anyway, we'll discuss. So DFS based on what? LIFO, right? Last in, first out.
Yes, sir. That I don't understand, sir. Actually, last in, first out, first, then that thing.
And BFS is based on FIFO, first in, first out. Okay. So here last in, last out, and here first in, first out. Okay. So if you look at the example that we have taken, okay, of that particular graph, let me draw here like this. So this is A, B, C, D, E, F, and G here, right? Now, what is last in, last out? First, we discuss about DFS, right? So here we have explore a list. Initially, it is empty. So we are starting with the node A. So we are going to put a node A in that list. Okay. So here you can see from node A, I can go to B and C here, right? So I'm going to add a B and C. I'm going to remove A because I already explored. Then B and C are added in this particular list here. So according to the last in, last out principle, and we are saying that we're exploring node in alphabetical manner. Okay. So I've added B and C in the list. Is this fine? Because we are going in this direction. Okay. Now after B, where we are going? D and E, right? So I can go to D, I can go to E as well. So I'm removing B and I'm going to add D and E here in the list. But after B, I'm going to go to D here. So I'm going to remove a D as well. So in the list, what is remaining? C, comma E, right? Is this fine now? Do you understand this, what we have discussed?
Yes.
Sorry to interrupt, sir. So we can write the next column as a where we B and C. There is C D E or C D only.
Yeah,
The second one column.
Yeah.
C D E will be there or only C and D. Then D
No.
and E. It will be like that.
Yeah, so we are at this particular point. We are taking this B out, and from B we can go to D and E here, right? So then we are going to a D. We can skip this part as well. We can write a C comma E as well. Okay. So we have two lists. We have to follow two lists: explore and unexplored list, visited and not visited list. That is what you have to consider. So here we have a visited list. In that we have A. In that we have B. In that we have D. And in the explore list we have visited or explore list. Okay. And in the open list we have this particular element C comma E. Okay. So here we have visited or explore list, and here we have open list. Now in the open list, we already explored A, B, and D. Okay. Okay. Is this understood how we got C comma E here? Hello.
Sir, well, I have a doubt.
Uh.
I'm just clearing this concept. Sir, LIFO means last in, first out, right?
Last in, first out. Yeah.
Then the first element comes in the last, right?
Yeah. So whichever element will enter the last, that will come first. Like that. Okay.
Yes, sir. Sir,
Yeah.
for example, a question was asked, state the properties of DFS. Few options are given, where two options are LIFO and FILO. Can we say both are correct?
LIFO and
FILO.
FILO.
Yes.
First in, last out.
Yes, sir.
First in, last out. Yeah, this is also
क्या हो रहा है यार?
first in, last
But
out.
sir, go on, sir. But this is not the question which I get in this IIT Madras questions. But I got from the external, like I'm just studying my 12th standard, I get this type of question. I just selected both of these answers, but I get that no, it's wrong. But they just say that LIFO is the only thing correct. FILO is not correct. But I just said that it's conceptually it's correct. First in, last one means, so last in, first one means the first item will be comes under the last one. Like it's like a stack or a shelf having a rack of book, a rack of plate like that. But
Yeah.
conceptually it's correct. But why it's wrong?
This is basically stack, right? So we are putting one element A, B, C, D, and last in out means what? Like last in,
D
first
will
out,
remove
right?
first.
Yeah. Where it is.
But
yeah. This will remove first. Yeah.
then
C, then B, then A, like that.
yes, first element is removed at the last. Then FILO is also right now. Why FILO is wrong?
First in, last out. But we cannot apply this to anywhere. Like first in, last out, right?
Sir, but first, so last in, first out, and first in, first out, both are correct, right? Why? Then why?
Yeah, we have to check that. So we generally follow LIFO and FIFO. So in the case of BFS, it is first in, first out. That is basically a queue data structure, right? See, here the working will not happen, right? So last in, first out means what? Here we have this particular thing, DCBA. Now, can we apply this technique last in, first out? First in, last out. Can we apply this technique here, right?
Sir, I'm not able to understand why last in first out it is called.
So whichever the element will enter the last into the stack, that will be taken first out. This is
Like
what
for example, here we have got two list, visited and open.
open list. Yeah.
Yes. So how
Yeah,
it is like with respect to stack, how it is we are visualizing.
Okay. See, so here we have an empty stack. We are putting A first, then B first, then C, and then D first. If I want to remove the element, I have to remove from the top. Last in, first out element, like that.
Yes.
I cannot follow. I can actually go to a last in here, last element here. So first in, last out. But what about this remaining elements here? Which thing to follow here, right? We're only saying that first in that will be taken last here. But what's the order of this DCB? In which order we have to remove this?
DCBA.
No, first in, last out, right? So we have to remove this one, BCD, like that, okay? But we cannot, we don't have data structure for this first in, last out.
Sir,
In this
I'm not.
statement, it looks correct here. First in, last out, basically equivalent to first in, last out, basically equivalent to last in, first out. But data structure wise, I don't think it is possible here.
So I'm not getting it, sir. Actually, sir, like
Okay,
first.
you understand this one, C comma E, right? How we
Yes.
got C comma E. Now
Yes.
we don't have any other node to explore here. After that, which node to explore, we don't know. So we go to open list. Now here we are following a stack data structure, that is last in, first out. Now which element enter the last here in this particular list?
So E.
E here. Then we have to go to E here, like that. So what we have discussed, backtrack to previous unexplored node and then go to a node, that is what directly we are doing here, right? So we are going to E, right? From E, I can go to this F and G, right? So I will go to F, I will add G here, I will remove E. Again, I don't have any other node to explore. Then which node to explore? Again, go to this open list. Again, follow this last in first out principle. Again, we have to explore G here. Then we'll explore G directly. Okay. Like what we have done in the case of backtracking. So we are directly moving to this particular node here to this data structure here, DFS. Okay. BFS means simply this one. So here we have this node like this graph. So we are going level by level like this. So first we'll explore A, then we'll explore B, then C, then D, E, F, G, like that. Okay. So it's not a part of the course content, so we'll not go in a detail. But BFS goes level wise. Okay. That is basically Q data structure. Q means what? First in, first out a principle. So if we just have this B, this C, this D, E, and F. So first we'll explore A. We can add B, comma C, right? We'll explore B. From B, I can go to D and E. But according to the Q data structure, whichever the element enter the first, that will be taken out. So C was enter the first. So we'll go to a C then. A, B, then C, then we'll go to D, then we'll go to E, then we'll go to F, like that. But in the case of DFS, we'll go in that particular depth, and then we backtrack to a previous unexplored node. That is what depth first search and breadth first search. So here we are going breadth wise, like that. Okay.
Sir, in BFS, I understood first in, first out. But in DFS, last in, first out, sir, can you explain like how one node is entering and then last one is entering and then first one is out?
Yeah. So you can see like what we have discussed here. We have a starting node A, right? So we'll add A into a. We'll explore this. We add into explore list A. But from A, I can go to B and C. So I will add that node in B, comma C here, right? Then I will take B out. I will put B in the visited or explore list. But from B, I can go to D and E here. Then I will add D and E here. But here we are following that we will explore the node in alphabetical manner. That's why we are going in this particular depth. Or always a left node, we are assuming, right? Then we are going to D, but here don't have any other node to explore. Then we'll add D here. Now, I don't have any other node to explore. Which node I have to go? Here. So in the open list, I have C and E. Whether I have to go to C or E. How our algorithm is going to decide? Based on this data structure. Okay. So last in, first out. So whichever the element enter the last here, that is basically E, we are going to explore that directly here, like that. Okay.
Okay.
That's how DFS works. So we have discussed about backtracking to a previous unexplored node and then explore, right? That's how backtracking is happening here using a last in, first out principle.
Okay.
So don't worry, we don't have this much concept in our course. Okay, you will discuss this. We will learn this in our PTSC course in lot more detail along with the implementation using Python. Okay, so yeah, but this is about the first in, last out. Technically, like logically, it looks correct, but I don't think technically it is correct. Okay, try to explore about this last in,
Sir,
first.
sir, yes, sir. Yes, sir, just explored in
Sorry,
my,
your voice is breaking in between, Nitish.
yeah.
Is this for me?
Sir, his voice is breaking.
Nitish, your voice is breaking. Okay. Can you speak again, Nitish? Your voice is breaking. Okay, I guess some network issue is there. Yeah. Anyone, any doubt here about BFS, DFS? So don't go in detail for city course. Anyway, you are going to learn in our further course here. Yes, Nitish, you are audible now. Hello? Nitish, your voice is not audible. It's breaking. Okay. Any other student? Any doubt? in week 11 or week 10? Any concept? Okay. Yes, yes. Please send in the chat what you want to
Sir,
say. Sorry, we are not able to hear you. Can you paste your question in the chat? Okay. Yeah. So please paste your question in the chat. Okay. Anyone, any doubt here? You can ask still.
okay, now let me come. Sir, now it's audible? Oh,
Yeah. Go ahead.
okay. Chat box, it's okay?
Yes. Can you speak now? Hello.
Sir, now I'm.
Yes, yes, you're audible now. Yeah. Tell me.
Yes, sir. Sir, I just asked that to my AI. It says both LIFO and FILO both are correct, and it's technically both. If one LIF happens means FILO should be also happen. So it said everything is correct, but they said that we are just considering of the first element. That's why we are just taking the LIFO.
We're considering the. Can you repeat after that?
Sir, we are just considering of the first element, sir, because if we consider the stack or any list, we are just popping or appending for the first element only. So we
First
just
element.
considering of the first element. So we just considering writing LIFO, FIFO, first element only.
Yeah. That's what I said. It looks
Sir,
logically
I'm
correct, but
audible.
technically not possible, I guess. Yeah. That's what I said.
No, sir, it says that technically also it's correct. We are just considering of the first element only. That's the only problem.
Okay. Fine. Yeah. But whenever we say stack data structure, we always follow last in first out principle. Okay.
Yes, sir. Sir, can you just do some research in this and can you give me an answer for this question?
Yeah. We'll explore about this one. Sure.
Yes, sir. Thank you.
So could you discuss about some important commands like is key command?
Yeah.
Like some important which will help us in problem solving actually in exam.
So here we have dictionary. Here we have a list. Okay. In the list we have few functions. First one is last of L. Okay. Last of L is basically what? Last element we are saying, not the list. Last element. So if the list is 1, 2, 4, 7 like that, last of L will be only 7. First of L. First element of the list, that is basically 1 only. Now then we have init of L. Now init of L will be what? Initial element of L except the last element. Except the last element. And this will be a list. Okay, 1, 2, 4 like that. These are the element. This is basically a list. Rest of L will be what? Except the first element. That is basically 2, 4, 7. Is this clear? Any doubt here?
No, sir.
Yeah. Then we have
No,
member.
sir. No.
Members, right? Members L and E. So this will check whether E is present inside the list or not. If this is present, if E is present, then it will return true. Okay, otherwise it will return false. For example, member L, 5. Now 5 is not present inside the list, this will return false. If we take L, 4, 4 is present, this will return a true. Okay, it's about the member. Then we have length function in the case of list. Length of L will be what? Number of element in that list. Simple. Number of element in the list. That is basically in this case we have a 4 elements. So answer will be a 4. Right. So for list, I guess we have these functions only. Any other function, anyone for the list?
So is key function?
Is case deals with the dictionary part. Okay.
Okay. Please.
So this all are applicable to a list. Now here we have a dictionary. Dictionary consists of key value pairs here, right? So here we have key 1 and colon, then we have value 1, key 2, colon, value 2, like that. Okay. Let's say for example, here we have A colon 2, B colon 4, C colon 4, like that. Okay. In the dictionary, every key must be unique. So keys are unique. Value can be same, no worries, keys are unique. Now when we talk about is key, so this will take dictionary as an input and K, D and K. So here we are checking whether this key is basically present inside the dictionary or not. Is this key is a part of this dictionary or not? So if you look at the example here, is key T, comma C. Now C is basically a key of this dictionary. This is true. So this will return true. If I say is key D, comma F, F is not a key here inside a dictionary, then this will return false. So it will only check whether this particular key is present inside a dictionary or not. Okay.
Yeah.
And then we have
Okay,
keys
sir.
of dictionary D. This will give us list, very, very important, list of all the keys of dictionary D. For this case, here we have A, comma B, comma C, three keys like that. Okay. So is key and keys of D is basically list of all the keys in the dictionary. Any other function for dictionary? Yes, anyone remember? Here we have is key, then here we have keys. Yes, so member is also done about the list. Yeah, any other function you want to know? I think dictionary is
The nested dictionaries.
nested dictionary, basically a dictionary inside a dictionary here. So here we have D. So what we said, A is basically 2, B is basically a 3, C is basically 4. So here we have the key and the value. But if the value is itself a dictionary, A is basically a what? Again, a dictionary here. Let's say for example, 21F1, then we have Ram, 21F2, here we have Sham, right? Like that. And then again, here we have a different thing. So dictionary inside a dictionary is basically what? A nested dictionary here. Okay, so value can be integer, it can be a string, it can be a dictionary, it can be a list as well, like that. Okay. So whenever a dictionary is inside a dictionary, that is basically nested dictionary. List inside list, basically nested a list, we say. Okay, list of a list, we say. Okay, and how we can access this element? So here we have a dictionary. In square bracket, we specify the key, and the output will be that particular value here. So if I say dictionary D of A, so in this case, the output will be this entire dictionary here. That is basically from 21F1 around to 21F2, this sharp, like this. Okay, but if I want to find out this element here, so I can write D of A, then this is basically dictionary, and of this dictionary, I want the value for this particular key, 21F2. And the output will be for this particular case will be a sharp, like that. Okay?
Yes.
Yeah. So this is about a dictionary part. Okay. So here, if the key is present, it will give us the value. Let's say, for example, I have this given dictionary, this particular dictionary. This line number 4, let's say for example, and at line number 5, I'm writing this one. D of C equals to this particular element. Let's say for example 5. But here we have a D, we don't have a C as a key in the dictionary. So what this will do, it will create a C here, key, and the corresponding value will be this one, 5, like that. Okay. So this is what dictionary will work. So D dictionary corresponding to the key, we are going to get that particular value here. And value can be anything. It can be dictionary, it can be string, it can be integer. If it is a dictionary, then to get that, to access that particular dictionary, we need to use the key of that nested dictionary, like that we have discussed here. Okay.
And sir, if it is a list, suppose a dictionary, a list inside a dictionary, suppose with B, we have a list, na?
Yes.
Then how do we access the element 3 of B?
So here we have D of B will be what? You are going to get 2, 3, 4 here, right?
Yeah.
So if you want to access the element, in CT course, we access by for loop or by using the first and last function here. Okay. So if I say for I in T of P here, right? And we are checking if you want to check whether the numbers are even or odd, if you want to simply print something, if you want to return something, then you can do that. Okay.
Okay.
In Python, we access the list by using an index from 0 to and -1 like that. Okay, but we have not discussed indexing in the CT course. In Python, you can understand in a better way because we can execute the code there. Okay, any other doubt?
Sir, the commands, the important commands in like the matrix and the graph part,
In
which
matrix and we
graph
don't
part.
have. No, in the graph, you should know how to draw adjacency matrix. Okay, so if we have given the graph, you should be able to draw the adjacency matrix. Okay, if the adjacency matrix is given, you should be able to draw the graph here. So simply whenever we have a two node I and J, if there is exist H between I to J, we'll say it's a one in the matrix. Okay, so let's say for example matrix M. So I comma J. So I J means what? I throw Jth column basically equals to one. One means there exists a H from I to J like that. Okay, so that's how create adjacency matrix. So please do watch the session. Like in the last session, we have discussed about this matrix and we have solved the questions. Okay, based on that.
So like create matrix is one command, no? Create matrix, empty
You
matrix.
create matrix n cross n. So it will create a matrix of n by n elements. If we have n basically number of nodes in the graph, let's say for example 5, so it will create a 5 by 5 matrix like that. Okay. So this will create a 5 by 5 matrix. Square matrix.
All elements 0.
Yeah, initially we assume all elements are 0, and whenever there is h from I to j, we said it is equals to 1. Otherwise, it is 0. Okay.
Yeah.
Yeah. And after creating a matrix, we have some code, and in that you can see sometimes we replace that by a empty dictionary or some element or some list also we can do. Okay. Like that. And here the matrix will always access by rows of m or rows of or columns of m. So you can see these rows or columns of m. This is basically nothing but list of vertices. Okay, list of vertices. For example, 0, 1, 2, 3, what we have the vertices, that is basically list of vertices.
So rows of m and column of m, like it represents.
M represent matrix here. Okay, so rows of this matrix, columns of this matrix, basically same thing, 0, 1, 2, 3. So it's a square matrix of n cross n, right? It will be from like that, all the vertices here. Then we can apply a for loop for I in rows, and then for j in column, then I j equals to 1. This means there exists a h from I to j like that. Okay, we'll see like that. So please try to solve some previous year question, previous term question. In that we have very good question based on the graph. Okay, it's easy only, not that difficult. Okay, so please try to solve all the PHGA and the previous term question. That will be good enough for an end term exam. Okay, any doubt now from week 10, 11 or any other week? Okay, that's it from my side then. From the next session, we'll do a revision for week 1 to 12, week 1 to 11. Okay. Okay, thank you then. Bye-bye.
Thank you, sir. When will you start the revision?
Friday session. From Friday.
Friday session?
Yeah,
Okay,
Friday,
sir.
Saturday,
Thank you.
Monday. Yeah.
Okay, sir. Thank you.
Thank you. you. Bye bye.